share my screen.
Okay.
Is that coming through okay?
Yep. Yep, we see it.
All right.
So hi, everyone. I'm Mark Champagne, co-organizer of the Boston Closure Group. This evening's presentation is on Protojure. It's being presented by Greg Haskins, and we're excited to learn about Protojure and all its uses. So we're probably going to have about, we think, between 45 minutes and an hour and a half of presentation. We'll see how it goes, and Q&A, and we'll take it from there and see if we need to take a break and continue on. But let's go ahead and get started. So go ahead, Greg, take it away.
All right, thank you very much, Mark. Hello, everybody. Thank you for attending. So I just wanted to get a chance to talk about this project that I open sourced a few years back. Just a moment. Just before I get started, I'll just give you a little background on myself. So my formal training is actually as an electrical engineer, but I've spent my entire career in the software industry, primarily in financial services and telecom. And I've worked as an engineer and architect and a technology executive, but I've always been hands-on. So I'm always writing. I try to code every day. Not always successful, but I try to. But my current role is as a co-founder and CTO of a company called Manitou. We're trying to solve some privacy and cybersecurity issues, and I'm pleased to say that one of the benefits of being a co-founder is we're a Clojure shop. So I'm very excited about that. I've been playing around with Clojure at least probably 6-7 years now. I've introduced it at various companies. In fact, when I jump to the background of the project, you can see that Protojure actually started as an internal project while I was at State Street Bank. So I was leading a Hyperledger team there, and it was Clojure based as well. And we developed Protojure out of a need to have kind of first-class support for Protobuf and GRPC. Prior to that project being created, I used to be maintaining one of the more popular forks on GitHub for the original Clojure support for GRPC, which was based on Java interop. So there was, I think it's Ninja Judd, I think is his name or her name, had a project that hadn't been updated, and I kind of forked it and was maintaining it. But the interop, especially on the GRPC side, was a little bit rough. So from that was born native Clojure support while we were at State Street. And I eventually, if anyone has ever been at a large company, particularly a large bank, who doesn't typically do open source, it was kind of no small feat that we were able to get approval to open source the code, but pretty proud that we did that. That came out around 2019, pushed it up onto GitHub. Not very creative, not very clever name for portmanteau of protocol buffers and Clojure is how the name came about. We released it under the Apache license, which aligned with what most of the GRPC community was doing with their code. I don't think that's what Clojure uses, but that's what the Protobuf community kind of uses. And it also made the State Street lawyers happy. So it all worked out. But today it's used in production. We're using it at Manitou as a kind of a key part of our microservice architecture. We have a mix of Clojure and Golang microservices that talk to each other with gRPCs. We use Protojure for sending events over Kafka. We persist things into databases, etc. So it's a pretty battle-tested and used in production component of our solution here at Manitou. I'm actually going to kill my camera because I'm on a very low bandwidth hotel Wi-Fi, and hopefully that will make this not be too choppy. Is my audio coming through okay, Mark?
Yeah, we hear you fine.
All right, perfect. All right, so moving ahead. So I'm going to assume everyone is familiar with Protobuf and Java. I'm not going to go into the great details about the background and the ins and outs of how to use it. But in case you've never heard of them before, this is a super brief introduction just so that you have some context and can follow along. But from the community, from Protobuf, they define it as a language neutral, serialization mechanism. So it's based on the concept, like many of them are, on an interface definition language that you compile with something into native language bindings. The core platform actually supports maybe a dozen or so languages, but they also make it extensible through a plugin architecture. So Protojure fits into that by being a plugin in that ecosystem, right? So we're not part of the upstream project, but it's a plugin that you can add to the upstream project just by installing the modules that I'm going to talk about here today. For background on GRPC, they define that as basically a high performance open source universal remote procedure call framework. It's based on protobufs, so the messages that are sent back and forth between RPC clients and servers are based on protobuf definitions. The claims to fame in GRPC are really leveraging protobuf's kind of space efficient and high performance encoding. So, the way protobufs are serialized on the wire is generally considered fairly compact and high performance compared to, say, XML or whatever. So it leverages that high performance ecosystem of protobufs. They have a very strong mechanism for forwards and backwards compatibility too, so it takes advantage of that. This first class support for bidirectional streaming, and it's based on HTTP2 encoding, which allows you to kind of, have higher performance interconnects, which is kind of critical on, microservice architectures where you have lots and lots of connections on a mesh. So what I want to talk about is how Protojure kind of plugs into that ecosystem. I figured I'd start with a really basic, getting started overview. So I'm going to assume you've already, install the Protobuf environment. If you haven't, you can follow this link. I will be sending these slides out at the end, by the way, so you'll have access to all these links. But there's tons of instructions out there about how to get the environment up and running. I'm going to assume you already have that. So really where our journey starts is installing Protojure on top of that environment. There's two main components. One is the plugin itself. So there's a runtime executable called Proto-C gen closure that if you install into your if you make it executable and install in your path, it becomes available to the Proto-C compiler. And there's a runtime library that's available up on Clojars that you can add to an application, a Protojure-based application to leverage all of the support infrastructure. But anyway, so there's instructions here. Again, I'm going to share these slides, but you can download it, install it, make it executable, and now you have Protojure capability added to your general Protobuf environment. So real simple basics, we start with that interface definition language. In this case, they call it Proto. We use the Proto 3, we specifically support the Proto 3 syntax. There's also a Proto 2 syntax, which I think largely works so that we don't generally test it. So I don't know if there's any gaps there, but the Proto 3 specification is the newer one. And you define basic things like messages and services in this Proto interface definition language and then run the Proto-C compiler. So that part's actually not specific to Protojure at all. That's just the general ecosystem of protobufs. Where we come in is the fact that if you notice in the middle there, I'm running -- closure out. So we're essentially adding closure support to that Proto-C compiler through that plugin mechanism. So the way you invoke the tool is the same. If you use protobufs in any other language bindings, it's the same exact syntax. It's just you specify closure out and we'll generate native closure code. One of the things I'll point out here is if you look at the definition on the left, we have things like package, com, example, address book. That becomes the namespace of the code that we emit. So if you look on the right, you can see the CLJC file as some more namespace. And the messages and things like that that are in that file become things like def records and whatnot. And we'll get into that as we go through the talk. So I just want to keep in your mind things like the com example address book namespace, as well as person as a message, and that person has, in this case, an attribute for a name and an email and a ID, etc. So as we look at the environment, I'm going to point those things out where they kind of come to the surface with Protojure. But before we do that, you need to get generally like a little REPL environment going. I use Lineagen. I'm sure this will work on any of the environments that you have if you prefer Depth Eden or whatnot. The main thing is that you need to set up dependencies for The Protojure library itself, that's that runtime component I mentioned. That's all up on Clojars. There's a Google Wellknown Types library that we're going to talk about a little more in depth that you can optionally pull in. That's that 091 reference there, as well as the upstream Java Protobuf library. In this case, I'm pulling in 3.17.3. Doesn't matter how you pull them in, whatever, use your favorite tool and fire up a REPL. Once we do that, the last thing I'm going to point out here on the screen is that I'm pulling in and requiring that common example address book namespace that we just compiled and aliasing it as example for convenience. So moving ahead, creating a message is one of the most basic things that we can do. If you were to look at the generated code, we make def records for every protobuf message that was defined. And for each of those def records, we actually define a function, a constructor function called new. And the reason why we did that, it actually follows the map semantics from normal def records. We added a different method in addition because it has Protojure awareness. So if there's nested messages, et cetera, it can dig through the hierarchy and make sure that they're all initialized with the protocols that we use for serialization. So it follows map semantics, but you just need to use new. But a few other things, the person reference here is one-to-one with the messages that we had in our proto file. It's a map-oriented kind of experience. So you initialize it as a map. In this case, I'm initializing the name field with the string Jane Doe. And you can see we end up with a record being created. But in this case, the other fields are also populated, and that follows the Protobuf specification for default values. So integers are 0 and Booleans are false and strings are empty, et cetera. So we'll initialize all the fields according to Protobuf. The language specification has default values for those things. Actually, as an aside too, I'll also mention that one of the neat things about Protobufs is that it will elide default values from the wire, right? So if I were to send this message across the wire, it would know that 0 and empty strings, et cetera, don't need to be sent, and the message becomes incredibly concise. But keeping that in mind, the real interesting thing is, how do we actually serialize and deserialize it? So one of the most core operations on the platform is a function available in the Protojure Protobuf namespace that's in that support library. So into PB, into Protobuf function will invoke the serialization protocol on those def records that we created and generate bytes. So in this case, I'm taking that same exact person representation of a message, initializing it with the name equals Jane Doe, and I'm serializing it to bytes, and that's suitable for placing, on the wire or in database or wherever you need to serialize. And there's a converse function that's created, and again, in that generated code, PB into the function, PB into the record, in this case person, to take bytes and turn it back into a record. So that kind of is the most basic round trip operation in Protojure for taking a protobuf definition, generating a message, and then serializing it onto the wire and pulling it back and reconstituting it. So everything we're going to do from here on out is kind of based on this core premise. One of the things I want to talk about before we get into some of the details of GRPC is, that Google library I mentioned at the beginning. If you're familiar with Google protobufs at all, you may come across what they call well-known types. So there's a set of protobuf messages that are defined as a set of protos that Google uses in their own APIs. Like if you ever use Google's APIs, they have a lot of these types in use generally. And they're used also just heavily within the protobuf ecosystem in general. There's a whole bunch of them, there's several dozen. I actually don't use most of them, but I do heavily use 2 of them, which I'm going to talk about in depth here because we have a few support functions built into Protojure to help you use them. But if you're ever curious, you can follow the links here and read about them. But the main thing to take away from this slide is that if you are using any of the Google well-known types, there's a Protojure support library for them. And basically what that means is we've taken all their protobuf definitions for those well-known types and compiled them with Protojure, making them available for use in your Clojure apps alongside the rest of what you're doing with Protojure. So again, there's a Clojar's Gav target you can pull in and use that just like any other library. So the two that I wanted to talk about in specific, the first one is the any type. So they define an any type structure that allows you to basically have type reflection, or basically typing of a message across the wire. So the any object itself includes information on how to, the type of objects that's been encoded so that you can reconstitute on the other side. And to do that, there's really two components to it. The first is the actual support for the any object itself, which you get from that well-known library I just mentioned if you pull in. But the other part is the runtime support. And so what we've done is we've added a namespace to the support library called protojure.protobuf.any that has a few helper routines. So if we look over here on the upper right, you can see I'm basically doing the same thing from the first example where I'm creating a new person message. And what I'm going to do just below it is using the any substrate is encode that as an any type. So what I should have talked about first is if you look over here on the left, I have this message event with an any payload in it. So this is a very common type of thing to do with an any type. We do this at Manitou with sending messages over Kafka, for instance. So we have kind of a common event wrapper that is the first class message on Kafka, and then inside it has an encoded any type for specifics about that particular message. So the way you get data, the way you get an object in and out of this is you can use the Protojure Protobuf any namespace, and there's a few helper functions, so into any and from any, and if you use that, we'll encode it according to the rules for that any type in a way that can be serialized and reconstituted, compatible with any other language that knows how to speak the any type. So one of the things that's a little interesting and also a gotcha to pay attention to here is that when you generate the classes, when you generate the def records from the Protojure, the Protobuf definitions, we generate type reflection information as part of that def record. It's a protocol that's emitted with the code. And there's also a substrate that will register that type with the type system, making it available for you to reconstitute a message that comes on the wire. That's only going to see it if you've actually required that namespace. So one gotcha that we sometimes run into is someone will add a new message type and they don't require the namespace. So then when you go to reconstitute the any, it shows up as an unknown type, right? So you just need to make sure to require any namespaces for any types you're trying to import, and everything works pretty seamlessly. The other thing I was going to mention that I use very often is the timestamp type. So Google's defined a timestamp as basically a seconds and nanoseconds component sent as integers. And we have this little helper routine over here on the right that we use with CLJ time. Basically, I deal with CLJ time objects within the code, and I'm just encoding them to the Google timestamp type on the edges. And this is a set of routines that we use heavily to do that. I actually plan on putting this into the Protojure upstream. I just need to do it in a way that's not annoying because I don't, not everybody may be using CLJ time. Maybe there's a more general way to do it or whatnot. But I've had people ask me in the community of how they do this, and I always dump this code snippet. So I just need to formalize it. But that's how we do it. Works very well. And that's how we're transporting time across the wire. So that being said, what I wanted to do now is dive into GRPC. So, GRPC, as I mentioned, is based on, its remote procedure calls based on top of protobufs. And we built Protojure to support them as first class. One thing that's a little bit strange about our implementation is that a lot of the protobuf and GRPC ecosystem treats them as separate. So there's a plugin or a built-in language support for protobufs, and then you use a different plugin, oftentimes from the GRPC community, to get GRPC support. But with Protojure, we actually built both functions in to the one plugin, and I'll talk about how to invoke them properly. But before we get started on that, just a high-level kind of overview of how GRPCs work is there's an aspect of the grammar for protobuf called service. And you can see here on the left, I've kind of created a really simple proto definition for a service called greeter that has one function called hello, and it's spec'd to take a person Protobuf messages as input parameters and returns a hello response, Protobuf messages a response. And we're going to talk about how you would actually build both a client and server based on this specification. Obviously, it's a silly example, but you could extrapolate it to more complicated ones. So how we do this with Protojure, we're going to start on the service side. And a few things to point out as a overview. The gRPC services with Protojure are really designed to be, well, I would say we tried to be as idiomatic closure as possible. So kind of maps oriented, so maps in and out. We can do that because the Protobuf specification is very specific about which Protobuf messages are used as inputs and outputs, et cetera. So we do the Protobuf encoding that we just walked through in the previous section. We do that for you implicitly when you're using the gRPC section. We also use core async based streaming. So when you're using gRPC's native input or output streaming, it's core async based from the Protojure perspective. And we offer first class support for pedestal. We're not specific to pedestal. We can support really anything. If we had support written for it, just for pedestal is what we targeted. So this first class support for pedestal today, I think it would totally be possible to support other things like Ring or whatnot with more help, with more support in the library. So one of the things we did to make this all easier is we created a line engine template, not surprisingly named Protojure, that you can invoke. So if you say lean new Protojure foo, it will create a new Protojure service for you. It's based on the pedestal service template. So if you ever use that and are familiar with pedestal in general, this should be very familiar. Essentially, we took the output of the lean new pedestal service template and augmented it in a few different ways. So the first is that we added an example proto file. So that's the address book proto reference there. That's actually just the same protobuf I talked about in the first section that has the person and address book kind of pieces in it. We added a make file to just invoke the proto C compiler with the right switches to compile the proto from the resources file. We've also modified the code in maybe half a dozen to a dozen places and annotated them with comments that have proto C gen closure in it, so you can kind of search through and see where the places that we touched. And then lastly, we added a few new dependencies that were needed to work. But otherwise, it's hopefully very familiar to you if you've worked with pedestal before. So I mentioned earlier that Protojure is designed maybe a little bit oddly in the sense that it does both Protobuf and gRPC in one plugin. In the way we do that is the gRPC is optional and the Protobuf is implicit, and we manage that through parameters to the closure out switch that we've added to Proto C. So earlier we talked about compiling the address book, and we added -- closure out source, etc. There's a few optional parameters that you can generate the optional client and or server code by putting those switches in front of the path as we've done here. And again, this is standard Proto C plugin interaction. This is how you specify parameters to any plugin. We've just leveraged that mechanism here. If you do so, we'll omit additional code. So if you look over on the right, you can see the familiar kind of structure for COM example address book that we covered earlier, but we now have an additional namespace for greeter and both client and server, and those are, as not surprising, related to the fact that we added those switches. So for every service definition in your proto file, we'll generate a namespace that's based on the package name and the service name, and then separate it by client and server. It would be highly unusual, I think, in the real world to have one project have both the client and server to the same spec, but for simplicity, I'm just doing them both here. I would generally expect you would be picking one or the other in a real world project. But anyway, so if you generated this from the template, the Protojure template, you can just type make all and it will build, it will run the Proto C compiler for you with the right switches and generate all this code. So that kind of gets you up and running. And at this point, you actually now have an environment that you could just do lean run, for instance, and it would fire up a web service listening on localhost port 8080, and you could serving the gRPC's for the greeter service, and you could interact with it, including from other languages, etc. So it gives you a nice bootstrap to just start playing with the project. Few things I wanted to point out. As I mentioned, we're based on Pedestal, or we support Pedestal as a first-class engine. And so as such, when you're using that Pedestal support, the way we've built it is that GRPC service endpoints become defined essentially as Pedestal handlers. You're not going to use the def handler macro as you would with a standard handler, but under the covers, we're implementing a handler for you, and it surfaces as a protocol that you have to build. So for every service definition, we'll spit out essentially a def protocol, and then it's up to you to implement that protocol, and the runtime will wire that protocol. Your implementation of that protocol gets wired in as a def handler on top of your Pedestal stack. One really neat thing about that is you can have it live alongside other handlers. So we oftentimes have, there might be REST endpoints or some, whatever different types of HTTP endpoints in one service, and gRPC just being one of them, and we'll put them together. Also, you can implement multiple Protojure gRPC service endpoints from one service, et cetera. So it's pretty flexible, plugs right into the Pedestal kind of interceptor handler ecosystem quite nicely, and is compatible with all the existing interceptors that are out there, whether you want to do auth or whatnot.
A quick question.
Oh, sure.
Sorry. So I think of Pedestal sometimes as a web framework, and just to be totally clear, this is back-end only stuff, right? I mean, I assume that there's no web client support here, no Clojure script or anything like that. This is strictly back-end. Is that true?
So that's actually, I guess, a complicated question. So I would describe it as, so from the back end side of things. So this project provides the ability to build Clojure backends with Pedestal, and you can build Clojure JVM based clients to talk to any gRPC backend, regardless of whether it's Clojure or not. What's actually missing, although it's on the roadmap, is Clojure script support. So basically being able to generate a Clojure client for the browser or for a Clojure script targeted environment is possible, but not supported yet. So I'm hoping to actually get that in at some point. But right now, what we're talking about specifically is JVM backends and JVM clients. But again, since it's language neutral, the other side of that connection can be something else, including we actually have Clojure script clients talking to our Protojure backends today using the gRPC web mechanism. We can talk about that. That's actually kind of neat, but it's a little bit awkward. I want to get it first class. It's not a great experience today from the developer perspective.
So at least both Protobufs and gRPC already exist as web clients, libraries that you can.
That's right.
You can leverage. Okay.
So in that's exactly what we do at Bantu. Our front ends are Clojure script based. They talk gRPC web, and then we can talk about the mechanics of how it goes through. It's a little bit awkward, but it does work.
Great. Thanks.
One thing I will point out is that in order to get this all to work, we actually created our own custom Pedestal chain handler. If you're familiar with Pedestal, if you think of it as kind of like a stack for interceptors and whatnot, there's usually a chain handler at the beginning, and then a series of interceptors, and then your handler at the other end, and they talk to one another. We actually built a custom chain handler, so it's kind of the thing that sits at the front of the stack. And the reason we built our own was at least 2 or 3 years ago, whenever we started the project, the support for HTTP2, which is what the normal gRPC protocol uses, was not fully robust in the upstream Pedestal chain handler. And there was some other specific requirements around gRPCs, like they leverage HTTP2 trailers, et cetera. So I ended up building our own chain handler. I'm not sure if Pedestal is moved to actually support HTTP2 better today, and maybe it's no longer necessary. I'd have to reevaluate that. But we had specific requirements around HTTP2. We also had to augment the request context to add a few extra things. So adding first-class support for streaming was something we add. So we're adding extra extra variables to the context. And we also added support for what I'll call disconnection notification. And we'll talk about that in detail in a moment. But the main thing I'm pointing out here, as you can see, from this code snippet below, that has that annotated comment I mentioned, that we've decorated all the code with anything that needs your attention. This is the part where we're registering the specific Protojure chain handler into pedestal. So once you've done that, essentially, your task to actually build a service is to implement the protocol that I mentioned, the code, the Protojure plugin generated for you. So if you were to crack open the server.cljc file that was generated, you would see that in this namespace com example addressbook.greeter.server, there would be a def protocol. And in that def protocol, there would be functions for each of the RPC functions in your service. So if you recall from our earlier when we looked at the proto, we had service greeter, RPC hello, right? So one-to-one with that. So your job to implement the service is to basically implement the protocol. And in this case, we're going to pull in, create a def type, pull in the service protocol definition, and then implement those functions. So I'm implementing, in this case, the hello function, and a few things to point out. So one is that we define the input parameters on the request context as gRPC params. This kind of follows the way most of the other pedestal interceptors work, like you have JSON params or body params, etc. So we take the input message and decode it based on the specification of your proto, and stick the decoded map into gRPC params. And then it just becomes a natural thing you can destructure or whatever to get the field values out. So in this case, you can see I'm destructuring for the name key. We do the same thing on the output side. So by putting a map into the body, the map that we return to pedestal, the body basically is implicitly encoded as a protobuf message and sent back. So if you recall the original spec, we had person with a name field, we had hello response with a message field. That's exactly what this is doing. So maps in and out as a first class kind of aspect of the design, and Protojure will manage the encoding and decoding to protobufs for you. One side note here, it actually is not necessary to return status 200. I don't think it's actually necessary even with just pure pedestal, but it's especially not necessary for gRPCs, because gRPC's specification mandates that all the requests return 200, and any errors are at a higher order message called gRPC status. The actual Protojure interceptor that's right below this will ignore that. Even if you set a 400 here, it's not going to take it. You have to set a gRPC error instead. But I just wanted to keep it as pure kind of pedestal as it could. So this looks like a, more or less like a standard pedestal handler, but it has the gRPC aspects to it. So that's a non-streaming example. So in that case, neither the inputs nor the outputs were streaming. But if you add the stream keyword to either the input or the output or both in your protobuf, that builds a streaming implementation of that function. So you could either have your inputs be streamed in from the client to the server, or the outputs streamed from the server to the client, or both, depending on what you're trying to do. When you do that, Protojure presents a core async based environment. So we support both, the client and streaming, client and server streaming, and we do that by changing around the request context and the body response a little bit based on the fact that they are streaming types. So when you have a client streaming function where the inputs are streamed up from the client to the server, rather than getting a map for the gRPC params, you'll actually get a channel. You'll get a core async channel, and you'll receive a message. One message on the channel equates to one protobuf message on the line, and it will close when the client closes. So a very natural kind of closure core async experience. The messages on the channel are already decoded in the same way that the parameters were decoded for the non-streaming case. So you'll just get a sequence of maps, and you can go do whatever kinds of things you need to do based on that core async channel. On the server streaming side, the way it works is you return a channel in the body instead of a map. The only side note I would make about that is that you can't just return any channel. You actually have to return the channel that was given to you in the request context called GRPC out. So the channel that we need you to put messages on comes to you in the request, and you basically grab it and put it in the body to kind of acknowledge the fact that you're initiating a server streaming event sequence, and it again behaves the way you probably expect. So every message is a map that will be implicitly decoded to Protobuf, and you close it to signal that the stream is done. One thing I should point out is that when you're doing streaming, there's a few considerations you need to think about. So I guess first I'll start with the side note that if you've ever used Pedestal, you're probably already aware that it supports asynchronous operation already. The way that Pedestal works for that is you essentially, instead of returning a map like that status 200 body that we talked about, you just return a channel. And once you return a channel, that signals to Pedestal to put you into async mode. And you essentially need to close the, you need to write a map into the channel that you've returned to signal the completion of the function. So that's a first-class Pedestal thing, and Protojure just builds upon that. And so the main consideration there is that we needed a way to support disconnect notifications, because if you build us, we have lots of things that you could subscribe for an event stream in our product. So we'll have a server streaming design where the client comes in, subscribes to something, and then we open up a streaming channel, and then the stream will just send events as they happen down on that channel. But sometimes the client goes away, right? And if you've ever built a subscription server with, say, Golang or whatnot, they have facilities for you to get notified when the client goes away. And so we've added that here as well, and that comes in the form of a closed channel. So we add to the request context a closed channel key, and it's just a promise channel that will signal if the client disconnects. So we'll just have the common pattern of kind of alting on, something that's, sending, receiving messages from, say, Kafka and on the closed channel. And if, either of them close, we shut down the server streamer. Pretty straightforward stuff. But that was something we had to add because we didn't have a way to have this kind of long running operation with pure pedestals. So we have that closed channel. So that being said, I was going to jump into the other side, which is building clients. So when we built the client side, again, we kind of were trying to build it as idiomatic as we could. It's based on maps in and out, just like the server side. And again, core async based streaming. I guess the one thing that's a little bit different is, on the server side, we're talking about pedestal. On the client side, one of the dominant traits is that we have a bunch of promise-based defins that you use. So almost everything's based on a promise. The one gotcha when you first learn to use it is remembering to dereference them. So with that said, let's just take a look at what this actually looks like in the real world. So there's a namespace in that support library called grpc.client.providers.http2. It has support for connecting a JVM client over HTTP2, like we were talking about at the beginning. The plan would be to add, providers like gRPC Web or something like that here, so that we can have ClojureScript apps use Protojure as a first-class thing. We don't support that yet today, but if you had a keen eye, you may have noticed that all the code that is generated is CLJC. So I hope to, since it's already JVM /ClojureScript neutral, I hope to add that support at some point in the future. It's mostly a matter of support library at this point because the plugin is already generating platform neutral code. But anyway, one we do support today is the HTTP2 on the JVM. And so just to kind of, high level overview of that, in that HTTP2 namespace is a function called connect. And you can see down here, I'm creating an instance of that connection, specifying the URI. In this case, I'm going to connect to the local host 8080. You would obviously plug it into wherever you're actually connecting to. And I'm dereferencing it to get an actual client object. So you can, because it's promise-based, you can of course tie these into asynchronous flows and promise channel handling. But The simplest is to just deref it on the spot. So I'm going to take that def client and use it in this next example, where we actually are going to leverage the greeter code that was generated earlier on. So you'll notice I'm just doing a require on the greeter.client namespace, aliasing as greeter for simplicity. But on the line below it, I'm actually going to invoke the hello function. So in that namespace, I would expect, again, kind of a one-to-one with all of the RPCs that were declared in the service, in this case, greeter. One-to-one, there would be defens defined. So there's one called hello. And that function for the non-streaming case has an array of 2. It takes a client, which is what we created on the last slide for the connection, and it takes a map representing the input parameters to invoke. And again, just like on the server side, we're going to be kind of map oriented. We'll do the encoding and decoding for you implicitly. Again, this specification for the hello function on the greeter service takes a person object as input and a hello response as output, and you can see that happening here. So again, I'm dereferencing. It returns a promise, so I'm going to dereference this function. I invoke it with name Jonathan Doe, and it responds with the message filled in based on those parameters. So real basic stuff, but that was an end-to-end flow from a client to a server and back again. And it wouldn't matter if that was a closure on both ends, or it could be, Golang or any other language. They should interop accordingly. And in fact, we do at Manitou, our microservice architecture does run with both Golang and closure, which was a great way to shake out any interop bugs to make sure it works between them. So I can pleased to say it does do that.
Very cool. Craig, before we continue on, we have some questions queued up in the chat. Sure. Would you be willing to take a look at that?
Take a look at them, sure.
Start with John Anthony. He's asking about Messagepack and how does this compare?
Messagepack. So I'm not as familiar with Messagepack. So I started with Protobus because at a function at my job, I need to interrupt with Protobus, and I built it. I've never built anything with Messagepack, so I wouldn't be an expert on comparing and contrasting. One thing I can say about Protobus that I really like is, like I am familiar with, like, say, Avro and a few things like that. What I like about Protobus is that they basically separate the kind of the English or the names and the semantics from the actual binary format in a way that makes it really easy to not, like, inadvertently break compatibility. So what I mean by that is, let me go back to the beginning here. Bring up an example. All right, that's not a good example. Let's find a different one. All right, so for this definition of a person, I'm declaring this person message has 3 types. So it's a string name, an int ID, and a string email. But the for the wire protocol is what they call tags that are after it. So the equal 1, equals 2, equals 3. So the tag ends up kind of semantically representing the name field on the wire. So the actual English name of name doesn't appear on the wire at all. And so it does a couple things. Number one, the tags are generally very space efficient for representing the field, and they're also kind of language neutral, right? So if someone comes along later and says, I'm going to make everything bumpy case name, bumpy case email, it doesn't actually break compatibility because the wire protocol is based on the 1, 2, 3, et cetera. So as a protocol designer, I've really appreciated the ability, like Eric and I use this, not Protojure, but just Protobus in general, to build a really high performance, low latency, basically exchange environment for financial services. It ends up being, very efficient on the wire and very easy to, like, build protocols that don't break. They're not fragile. So I can't compare it with Messagepack because I don't know it, but that's what I love about Protobufs personally. So I'd be curious to hear someone who does know Messagepack kind of offer a comparison, but I apologize, I don't know it.
Yeah, this is John here. So I've used Messagepack actually quite a bit. And it does have some of these sorts of things, and it tries to, it's a binary protocol, and it tries to minimize the, you know, the space on the wire for the encoding based on the various types and stuff. And it doesn't, out of the box, it doesn't require, well, actually, it just doesn't require upfront typed message schemas. You can make them.
Yeah,
You can actually kind of create your own,
right.
and then tag it with a like what you're saying here, the message type ID, some kind of a message type ID like that.
Yep.
Yeah, so I was just more curious about, I mean, in a way, out of the box, it's basically more like the any type that you've described here.
I see. Yeah. Yeah. I know, like, one thing that's strange.
Okay, so we had just talked about Messagepack and its differences. So I think we are mostly done with that discussion. The next question is from Stephen Katz. He says, if both the request channel and response channel are long-lived, is there an implicit order that the responses must be sent, or is there another mechanism to coordinate the response to the request?
That's a great question. So I guess the way I would describe it is that typically, so most of the time when I've built these, you tend to be like, client streaming is actually not very commonly used, at least in my experience. So usually you're building a completely synchronous RPC, one request in, one request out, or you're building kind of a subscription model that you're making one request up and then you get a long-lived stream that terminates when it's done. That being said, there's no reason. So the way that you typically build these things would be for long-running things, you're going to use Pedestal's async handler model, right? So essentially you launch a go routine in what's equivalently the def handler, and then that runs. So if you were to do that, that go routine kind of becomes the context for that request. So you could very easily, and I think you would typically build something that is naturally coordinated between the request and the response, because you have that one core, that one go routine as the entry, as the controller. You certainly don't have to do that, but you would, I think, have to do extra work to get them out of order. Now, that being said, that's just with respect to that one flow, right? Obviously, other requests can be coming in parallel, and those would be operating independently. Am I answering the question, or am I in the weeds?
No, so I was asking specifically about the addition you've added for the RPC, right? You said that the request channel, that I could get multiple requests on one channel, right? And they're going to come in as a stream, and I have to return responses. So
oh yeah, no, that's that. I'm sorry, I didn't. If I said that, I misspoke. So if you step all the way back to the core GRPC being HTTP2 based, the normal flow for these things is that a client will open up an HTTP2 session with the server, and then within that, if you know the HTTP2 protocol, they have this stream protocol, et cetera. So for every request that you're doing, which is essentially another HTTP request, you're opening up an HTTP2 stream, and then there's a post request made up to the server, and it responds. If the request completes, it responds with an HTTP2 trailer and closes the stream. But that stream itself is completely isolated to just that request. So if you're making, and so on the Pedestal and Protojure backend side, for every request that comes in, it's essentially another invocation of the Pedestal stack up to a def handler that is optionally either handled synchronously or handled asynchronously in a Go routine. So there's no intermixing of requests end to end. They're going to go up, and you're going to essentially get, a def handler invoked on that one request basis, and it's isolated end to end from the Go routine through the pedestal stack through the HTTP2 stream all the way end to end. So they're not going to interfere with one another. And with respect to that request itself, you would have to do extra work for the request and reply to be out of order. And so that now you can get different clients or even the same client making other parallel requests, and they're all operating independently, but they're not going to be in the same stream or in the same Go routine or anything like that. Is that?
Yeah. So there isn't a barrage of requests coming across one channel, one after
That's
another.
right.
There'll be one channel. From the point of view of the service implementation, I see a channel, I take a request off of it. I know I have a response channel, I'll put the response on it, and I'm done with those channels.
That's exactly right. Yeah. So
Okay.
from that greeter implementation that I was showing you with hello, that would just be one request with one response. You'd never see any of the others at all. And if you were doing it streaming based, the channel that you get is dedicated to that request. So the only messages on that channel would be related to that request relationship.
Great, thank you.
You're welcome.
All
Was
right.
there other questions?
Yeah, we have several more. The next one was mine. I was just asking if there's TLS support, but I realize now that HTTP2 implies a secure transport. So I guess that's actually, I've already answered that for myself.
You are correct. It is required and it is supported.
Excellent, excellent. And I know you're in the privacy industry, so I'm sure that's top of mind.
That's right. Yep.
Next question was from Chris O'Donnell. He says, what's your experience with the client-side code gen? Have you found a good strategy to define common logic for things like timeouts and retries?
That's a good question. So I tend to build, so with us having a microservice architecture based on Clojure, we tend to have a lot of things that are both clients and servers, right? So you have a front end request service interface that on the back end invokes other services. So there's a Clojure. So we use a combination of a few different strategies. We're running, as Eric will probably be swearing at me because he always hates it. We use Istio as our service mesh, which does some level of actually, it does some level of the TLS and retry logic for you, just being a service mesh. But for where we're explicitly doing it, I also use a resilience. I can't remember the name of the library. I have to look it up, but it's like resilience. Resilience for Clojure, I think, is the one I use, which is based on resilience for Java, and it has constructs for basically doing obviously retries and things like that, but it also does bulkheads and stuff like that. So I tend to, my backend calls, we build our microservices as a CQRS architecture, and there's a gateway component and there's a backend command processor, et cetera. And so the gateway components are usually the ones that front end a public gRPC endpoint, and then they also often have one or more gRPC clients to other microservices for resolving things, etc. So those backend calls I tend to build with like that resilience for Clojure wrapper, and that does a lot of the retry logic for us. Another pattern that I use often is, so we've written this thing that I call the connection manager. The connection manager job is to, it actually opens a long-term connection from that, from that front end component to a back end component. It opens a long-term connection, and you actually send gRPCs not directly from the request context, but you send it through the connection manager. And that basically allows me to keep like one TLS session long-term with other parts of the service mesh. And the connection manager is basically a core async based kind of alts processor, which will just take a bunch of different requests from the request context and tunnel, serialize them into one, gRPC client connection to the back end. But, that, like we talked about before, each request on the wire and through the pedestal stack, et cetera, is discrete.
Neat, sounds elegant. So another question from Chris. Actually, Chris, did that answer your question?
Yeah, totally. Thank you.
So Chris's next question was, what were some of the pain points you encountered doing interop with the Java library?
So the pain point, so as I mentioned at the beginning, when I first started trying to do GRPCs with Clojure, there was in the Protobuf community, as I mentioned, they allow you to add plugins and whatnot to the upstream Protobuf. And if you go onto the community site, they have like links to all the third-party plugins that are supported, right? And there was always like at least 2 for Clojure that were there and have been there for many years. So when I first started out, I was using those libraries, and actually I ended up forking the Ninja Judd thing from GitHub, and it ended up becoming one of the more popular forks. Like people started using that as one of the premier supports for Clojure with Protobuf and GRPC. The Protobuf support itself wasn't terrible. So let me put the caveat in here. I hate interrupt. Like I try to avoid it with a passion. Like I always try to go as quickly into Clojure as I can, right? So when I have to do interrupt, I'm making a abstraction layer in front of it and trying to minimize it. But the interrupt to do the original, let's just call it like the Ninja Judd variant interrupt based Protobufs. Protobufs themselves weren't too bad. You still had to generate, you had to have the Java, the Proto-C compiler for Java compile the classes, but then there was like support routines in the Ninja Judd library that made it not terrible to pull those classes in. It was still a little bit of an awkward dance, but it wasn't horrible. Where I really got dissatisfied was where I tried to start using the GRPC aspects of it and trying to plug all the the Java ecosystem GRPC in just really frustrated me. So the generated Protobuf classes in Java weren't terrible, but I didn't like the GRPC side. When I built Protojure, with a Clojure first kind of native Clojure support, I still actually use the Java interrupt, as I alluded to in the beginning. You have to pull in the Java Protobuf Java library. But what I'm using under the covers is the serializers for the types. So instead of being like interrupt at the class level, like so I'm compiling in the person message into a Java person class and interrupting at that level. At the low level library, they have serializers for things like int32 or Boolean or string. So what Protojure actually does is it still uses those. So I'm not rewriting the actual core serialization functions from Java. The compiler, the Protojure compiler is essentially writing a def record that lets you deal with the fields in a Clojure-y way with maps, but under the covers, I'm still calling the scalar level interrupt. And that's really not bad at all. In fact, it worked out really well. I ended up, it was one of my first forays into, kind of some advanced macro work, which I had never done before. And I wrote macros that, you can kind of just take a list of the scalar types and it will expand into all the interrupt calls, et cetera. It ended up being not bad at all. So I would really classify my pain points were like trying to interact with the Java GRPC ecosystem was what motivated the creation of Protojure.
How's that sound, Chris?
Yeah, that's great. I have another question if we still have time and nobody else has questions.
Sure.
Go for it.
Cool. Yeah. So what are some things that you'd like to improve about Protojure? I know you've mentioned Clojure script support and adding those time serializers. Anything else?
Yeah, that's right. So on the very next slide, I would have had, if I hadn't lost my connection, I had a roadmap slide. So see, I wrote down documentation, Clojure script support, and performance optimization as the top of my list. So documentation is always, always, well, not always, but it's lacking. I need to get it better. And it's like, so having people come in and understand how to use Protojure, I think is, needs improvement. So that's one of the first things on my mind. That actually we have some documentation and it's not bad, but like I didn't cover a lot of the things that we covered in this talk today, like the streaming support as an example in depth, or like the any support, like all that needs to be added. Clojure script support. There's actually someone from the Clojurian Slack that did some work over the winter to support it, and it never got pushed through the completion, and I was distracted with my startup, so I never, really pushed. But I think that this person got it actually pretty far, so I should really reach out to them and see if we can resurrect that project. But like I said, I structured the output of the compiler as CLJCC for that reason, and the idea being we could just write a closure script version of the support libraries to support it. So I'm hoping it's not too far away. What I learned from the JVM implementation is that the Protobuf support's super easy. Like I wrote the Protobuf support, I don't remember anymore, but let's just say it was like, a couple of days, right? I cranked out the Protobuf generator, and it's like, oh, great. Let's take it to the next level. And it was the GRPC stuff that was like really involved. Like it ends up, needing a ton of work to get, if you know the GRPC protocols, they have this thing called LPM, or length prefix matching, and or I can't remember what LPM stands for anymore, but basically all the nuances of the GRPC protocol. It was one of those things where, the 80-20 rule really, kicked me in the butt, and it took a long time to get that all done. So I'm a little fearful that, the GRPC web variant of that will be just as complex, but I'm hoping at least minimally the experience of already building, the first gRPC would be not, would translate some. The thing that actually is, probably most germane, in terms of the project is on the performance side. So the first thing I should say is we like I said, we use it in production, and it's a critical piece of our production infrastructure, and it works really, really well, and I'm super happy with it. But most of the stuff that we do, I would classify as really short session RPC, or kind of like infrequent, streaming message kind of things. We're not putting large amounts of data through. In the way that I wrote the LPM support, I would really classify it as like a byte-oriented core async pipeline. So, like the messages, you start with a map, and then I'm encoding the map to a protobuf, and the protobuf goes to bytes, and then the bytes get streamed through the LPM, which does the segmentation and reassembly, for messaging it out on HTTP2 requests. And what we found recently is we were actually trying to put our what we call our artifact service. We have essentially essentially an encrypted S3 object store, and so S3 object stores by nature tend to have bigger objects on it, right? And we started putting bigger messages through Protojure. The performance was not great, and I think the biggest culprit was like the byte-oriented LPM encoding. So I really need to go. Like my background is actually in performance optimization. That's what Eric and I did at the London Stock Exchange. I need to apply that level of diligence to the transport to really shake it out. But that being said, I don't want to shy anyone away from using it, because we do use it for, mission critical RPCs. And as long as you're not putting, a megabyte message through it, it seems to work really, really well. I think it will only work better if I improve the performance, but it hasn't been a barrier so far. But that's one caveat. If you're going to put big protobuf messages through right now, you're probably going to be a little disappointed. I need to spend some time on that.
Cool, thanks.
Thanks for that. Say, I happen to have a question out of far left field, just occurred to me. So instead of plug into Proto-C, could this have been implemented with closure macros?
Yes.
Or is that just completely insane? I mean,
no, it's not. In fact, I've wrestled with this too. So the first thing I would say is that in general, the Protobuf community works the way that I built it, right? So the
Right.
Proto-C compiler does the parsing and generates the AST from the protos, and it spits the AST out in a very structured way to the plugins, and the plugins can turn it into code, right? That's the normal Protobuf way to do things. I've worked certainly with plenty of systems. In fact, it's funny. I've done most of my career in Clojure on the JVM, and I've done a little bit of work and I've done quite a bit of work on ClojureScript browser side, and I've done a little bit of work on ClojureScript on Node. And back when I was working on the Hyperledger project, they had a very Node-centric ecosystem. And so at one point in my Clojure life, I was doing a ton of work with, I guess what I'd classify as like, really hardcore kind of like back-end stuff, but it was closure script on Node, and I felt like I was like an island, right? It was like, I was like the only person on the planet that I think was doing this, because I was running into all kinds of weird, weirdness with support on our edge cases that didn't work, et cetera. And I was ironing them all out. Anyway, where I'm going with this is that back then, this predated the creation of Protojure. When I was using Protobuf, I was actually using this library called Protobuf.js, because being on Node, I was using the JavaScript ecosystem. And I usually like to make fun of JavaScript, like to no end, but the one thing I will say is Protobuf.js is awesome, and it does exactly what you're talking about here. So you don't have to precompile. It will actually, it will take the protos live and generate, well, in this case, JavaScript classes and whatnot. But from a closure script interrupt perspective, you don't know the difference. So you didn't have precompiled Proto C runs. You just took the proto file and you just used it, and it was really good at it. Like, so as much as I like to make fun of the JavaScript ecosystem, I was actually pretty impressed with Protobuf.js, and it was a runtime, compilation, and I don't know what the right way to phrase it, but it would do, I think, what you're looking for. So I have thought about that, because at this point, I've done a ton of work with running the grammar for parsing Protobus. I think if I just took like instaparse and put a grammar in place to understand the protobus, so that I'm not relying on Proto-C to generate the AST for me, it's totally doable. And then if you take the support infrastructure that I've already built in the Protojure library for serialization interop with the Java library, bam, you're up and running. So it's one of those things, like, if you had all the time in the world, I would have built it already, but the real world kicks in. But yeah, I think that's totally doable.
Oh, cool. Yeah, I'm glad to know I wasn't completely off base on that.
No, not at all.
All right. Anybody else have a question? So I have a suggestion.
Sorry, I didn't unmute myself fast enough.
Go ahead.
One of the things I noticed on one of the slides, you had the point that client and server are not often the same project.
Yep.
I was trying to figure out, so if I was implementing something where I like have a mesh of peers or so on, would every instance of that peer, whatever, have to essentially contain its own client and server?
Yeah, I could see that being the case. And that was incorrect of me to say that. Yeah, that's a really good example, because I've built peers like that before, where it is the client and server in the same one. Yeah, you're absolutely right.
So essentially then will become essentially inbox and outbox for the client.
Yep.
Okay.
In fact, that's a lot of our Hyperledger stuff. What did exactly that, right? Whenever you're building a peer network, it tends to look like that. So that makes total sense.
Okay.
Okay. Anyone else? Going once. So, so we could go two ways with this.
So
All right.
I mean, I don't have anything specific here, but if there's something we can revisit or whatever, I'm happy to. Is there a specific format you have for the summary portion, Mark? I apologize.
No, nothing specific. Did
Okay.
you already cover your ambitions around documentation?
Yeah, I think that's good. And I'm trying to think too, because we've gotten a few other requests from the community that I can't think of at the moment, but there's at least probably 2 or 3 other items I could add to this list. If I remember them, I'll send them out to the group. But I mean, otherwise, I guess what I would say is, I would love to have everyone's feedback. Try it out. Let me know what you think. Let me know if you, can think of anything that would make it more useful to you, and maybe start using it in your projects. I'd love to see that.
Do you have any other committers, or are you the only one?
Oh yeah, that's a great question. So the project was started under my team when I was at State Street. I was the primary committer, but there's a few folks. So Morali, I think, might be on the call. I'm not sure. I know he signed up. Morali, and then Matt Arkiwak And Eric, I think you're a committer too, right? And then there's been a few folks that have contributed patches over the years, just via GitHub, that aren't committers, but have been, contributors. And actually, there's a few folks that were on my team at State Street. So John Andrews and this gentleman named George. So that, there's been quite a few folks that have contributed, but I'm always happy to take pull requests and whatnot. If there's an itch that you have to scratch on the project, would love to have the contribution.
Fantastic. Well, we can deliver that message along with the recording when we publicize it on Zulip and Twitter and so on, if you like.
Awesome.
So I think that pretty much wraps it up.
Great.
Any parting thoughts for us?
Nothing from me. I thank you for everybody for attending. I know it's late, so I appreciate it. Thank you very much.
Thank you. This was
Yeah,
super interesting. It looks like a really well thought out package. I see a lot of advanced features and elegant implementation decisions. So it looks really solid, and I can see this being very useful to people who are doing enterprise systems, need high performance and high reliability in their back end messaging. So thanks.
Thank you, Mark, and thank you all.